Okay, this is geotrig lesson 9, day 2. So now, I gave you in the last lesson all of these postulates on why or what we can do that if you're given two triangles with certain things being congruent, that the two triangles themselves would then be congruent. So corresponding sides of the triangles are congruent, so therefore it leads us to say that the whole entire triangle itself is the exact same thing. We're going to use these to form proofs. Now, I'm going to read this because I think some interesting things here. Proofs, guys, is that deductive reasoning. Using one step to lead you to another step, which leads you to another step, and on and on and on. So as we keep finding more things, we are finding to a point where we have enough to say everything is the same, so therefore they are congruent. Okay? You may not necessarily, or I say you can't, just assume things. You have to come up with a reason why. If you're going to state that angle 1 and angle 2 are congruent, you better have a reason. Okay? You have to back up everything you say with a reason. And doing the old dad move there, or the parent move. Why? Because I said so. Okay? That's not a good enough reason, obviously, when you're talking about proofs. Because I said it is. Doesn't mean that those two things are equal. Doesn't mean that that has to be 90 degrees. Okay? So, there are some reasons that you're going to have, like vertical angles. You guys remember vertical angles? Yeah. So if you have two lines that cross, remember this angle and this angle are the same because they are vertical angles. You also know your zigzag pattern on parallel lines. Some of those are congruent or equal. You know those postulates from the last slide. So therefore, if I can find all of the angles to be the same and a side to be the same, I very well could say that they're both congruent. Again, I have something here. It says when we write statements of triangle similarity, or I could take it the step further and talk about triangle congruence. Those statements are the same. You list your vertices so that ABC, triangle ABC, matches very well with a triangle DEF, like we did on lesson 8. You guys remember that? Yeah. When a triangle is similar to another triangle, we kept our vertices in a specific order that matched. When we talk about triangle congruency, which is on this next slide, you have to do the same thing. Because again, it tells you the order the triangle is laid out and its sides. Are we good to turn the page?
No.
Okay. So, just like similarity, if I wanted to say two things are similar, we used that, we would use a symbol that looked like this for similar, correct?
Oh, yeah.
So that's for similar. Guess what? We use this for congruence, to say things are equal. It's an equal sign with the similarity little squiggle above it. So you guys have to use that when you're stating two things are equal. So if I have that statement here on the left, segment AB is congruent to segment CD. Is everybody okay with that? Yeah. What we're going to do, guys, is we are going to do a 2-column proof. I know this does not follow what the book does in this lesson, and necessarily they don't give the answers as a 2-column proof. I think 2-column proofs are the most simplistic way because it outlines statements on the left and your reasons on the right. Like I said, every time you do something, you need to back it up with a reason why, right? So, Sometimes, and not sometimes, almost all of our problems, you're going to be given information. It's either going to be stated as, this is a given. And then the answer will be, state this happens. You need to fill in between. So it gives you how to start it, and then how to end it. You need to find all of the steps in between. Now, this has only 3 steps. 1, 2, 3. Statement 1, 2, and 3. Reasons 1, 2, and 3. Statement 1 has reason number 1. Statement 2 has a reason number 2. Okay? Now, I do not want to see people doing this. 1, 1, 2, 2, 3, 3. That is not very convenient on finding or following your steps. Make sure that your steps or your statement is across from your reason. If you need to leave a gap, it means everything should have a gap. Like, leave the extra space in there to make them even. I want to be able to look straight across and say, there's your reason why. Okay? This only has 3 steps and 3 reasons. It's an example. There could be only 3 steps. There could be 5 steps. There could be 10 steps. However long it takes. Here's the cool thing. When we get to our next slide here, we're going to be given problems. Starting to give problems. Sometimes people can do these things in less steps than others. Sometimes people state things that are not beneficial to doing the problem. Hence, if I tried to state that 2 triangles are congruent, and you can show 2 angles and a side in the middle of those angles, you don't need to state that the 3rd angle is also the same. It's an extra step. Can you? You sure can. It's true. But just because you know 2 does not mean all 3 have to be stated. We're not looking for similarity. We're looking for congruency. Okay, you guys ready for this? First problem. Proofs. Here we go. In this problem, you have to be given, or you are given, that side or segment AD is congruent to segment BD. Segment DC. What is an upside down T probably represent, guys? It is perpendicular. Upside down T is perpendicular to segment AB. I want you to show me that AC, which is this guy, is congruent to CB, or BC, this guy. Notice they gave us a drawing. That was very nice. Notice, is there anything on this drawing? Nope. What do you think's a good idea when you're given a drawing and some information? I would put tick marks on there. I would put your angles on there that are true and you know. So, notice there's no table. So what we need to do is we need to make our own statement and reasons. Statement, reasons. 1. Again, we're jumping a little bit, as in we're not doing the paragraph proofs that the book is using in this lesson. I want you to actually write 2-column proofs. Number 1 statement, I'm telling you right now, list everything in the given. In the given, we are told AD, line segment, is congruent to BD, and DC is perpendicular to line segment AB. What was the reason? We were told so. or AKA, we were given it. The reason for statement number 1 should be the given. I'll let you guys in on another secret. When we finally get to the point where the book starts outlining these as two-column proofs or some of the worksheets that we work with, the book or the worksheets will sometimes split the given up. They don't list it all at once. I like to put it all as the first step. So you got to be mindful of that. Sometimes there's more than one given reason. It's because they took the two parts and split them up. 2. Reason 2. Okay, so before I get to 2, I was given information. I probably should state something. Like AD is congruent to BD. So aren't those two statements or two pieces congruent? Which means they have equal lengths, which means you put a tick mark on that spot. Would you guys agree? Now this is going to take us a little bit because by jumping to two-column proofs, you guys got to pay attention to the details. The details are going to change how we go about these statements because we haven't been exposed to this yet. Guys, what does it mean to be perpendicular? Right? They meet at what? What kind of angles?
Right angles.
Right angles. So, in statement, or the second part of the given, DC is perpendicular to AB. Here's DC. That's AB. So what do we tell about these angles at D? They are what? What are the angles at D going to be? They're perpendicular. They have to be. Seth, you just said it. What are they going to be?
Right angles.
Right angles. So, if I go to this drawing, I could put those little boxes in there. But here's the thing. You need to state that, though. You were given that they're perpendicular. I still need to go back in statement 2 and state angle. They use almost like an inequality symbol. Maybe I should be flattened out. They use an angle symbol. Here's a problem. Watch what I do. If I write this, does this make sense? Angle D and angle D are right angles. Does that make sense? It shouldn't, because what's angle D? Is angle D this one over here? Or is it this one? Or is it the one down here?
No.
So it could be any of those. So here's the problem, and this is why we need to start paying attention. If I'm going to name a particular angle that is not by itself, if I talked about angle A, where does everybody look? Boom, right here. If I talk about angle B, I'm looking at this one here. Would you guys kind of typically agree with that? But if I look at angle D or angle C, there's a couple choices. Which one? So now, that means I cannot use just D or C. I need to actually use 3 letters. I need to use the letters that make up the angle. Like this angle D right here starts from A, goes to D, then goes to C. I need to use the endpoints of the angle. So this would be angle ADC. What's the middle letter? What's the middle letter? D. What angle are we really talking about? Angle D. What would be the other angle then that we are saying is also 90 degrees? BDC. So, angle ADC and angle BDC are right angles. How did you know that? How do we know those are right angles? We do.
Oh, 90 degrees.
They're 90 degrees, but how do we know they're right or 90 degrees?
Squares.
We put the squares in. Why do we put the squares in? Because we said they what?
Oh, perpendicular.
They're perpendicular
Nice.
lines. Guys, the reason? Easy. Definition of perpendicular lines. Part of the definition of perpendicular lines is that perpendicular lines meet at right angles. So I can just write definition of perpendicular lines. Reason. I'm liking it. What do we have here? We have a side. We have an angle. We know those are in common. Is that enough to state the two triangles are congruent? Maybe I shouldn't have started off with this particular problem, but I like it. It's got a lot of different pieces that you're going to see over and over and over and over again. But, and it's going to use some of these things that we need to use all the time, so I might as well kind of hit you with this first. Is this enough to state that two triangles are congruent? Two things. Each one of those on the last slide had how many pieces in it? How many pieces are in this? Three. We only have two. Is that enough?
No.
No, not even enough to even try to consider it. Oh, wait a minute. It wants us to show this, right? This side and this side. So obviously it's not going to be straightforward to be able to pinpoint and say, hey, those are the same now. Can we get another angle? Maybe angle side? Can I guarantee these two angles up here are the same? Potentially. I think there's some possibility there. You guys would have to find it. Tell me what it is. I think there's a slightly easier one. What about this side? Can I state that this side's the same? I'm looking at this triangle and this triangle over here. That's what I mean by, hey, I want to make congruent triangles. Can I state CD is the same? Question. If you got a brother and sister, do you guys have the same, say, parents, we'll say? Generally, right? Why? Because you share. Because you share the same. Guys, you share. Listen.
Man and woman really love each other.
It's because you share the same parents, right? Generally, that's what siblings are. Hold on. Now let's bring it back to this problem. How can I say that this is the same? It's because they share the same side. Guys, do you guys see that DC or CD is the same piece in both triangles? This is kind of an interesting one. So I can state that CD, line segment CD, is congruent to line segment CD. The reason? We could say they're shared in both triangles. Both triangles have that exact piece. There's a name for that, though. We have a name, so I don't have to write that whole statement out. It's called reflexive property. It's kind of like reflection in a way. You see yourself in the mirror, it's the same person, right? So it's the same thing. It's reflexive property. The reflexive property allows you to state that two things, or the same thing, is congruent to itself. So guess what? I go to my drawing, and now you have another side. Hey, they have a side in common, they have an angle in common, and have another side in common. Do we have enough information to state this triangle on the left and the triangle on the right are congruent? By what postulate? SAS. So, for triangle, someone give me the order that they would like on the left. What's the triangle on the left? Give me the triangle. Triangle what? ACD. ACD is congruent to triangle. Now you have more work to do. This one's more interesting. I have to match it, right? What is the order to ACD on the right? It looks like it should be B, C, D. Okay? B, C, D. Okay, guys, the first triangle starts at A, goes up to C, and then down to D. The exact same copy of pattern would be B to C to D. Someone told me the reason was, what was that reason again? Side angle side. If I have a side, an angle in between another side, the triangles are congruent. So, guys, these two triangles, this one and this one, are congruent. And what does it mean to be congruent? Everything is the same to each other, right? Are we getting this or not?
Oh, yeah.
So, do we have enough information to state what they want me to say? AC, side length AC, segment, is congruent to BC. I'm going to say yes. AC, line segment, is congruent to line segment. Reason why? Would you not agree that parts in the same place of congruent triangles have to be congruent? Guys, if I took a photo of myself, I made a copy of that photo and put it right next to it, they would be congruent.
Yeah.
My left arm would be the same length as my left arm in the next photo. Would you guys agree with this? So, even if I took that second photo and I twirled it upside down, does it change the fact that they're congruent or not congruent? Because my left arm in one photo is the same as the left arm in my right the other photo. Would you guys agree with this?
Yeah.
These triangles are congruent. That means there's a way to make them match up completely. So, we have a word for this, or a phrase. Corresponding parts of congruent triangles are congruent.
Congruent. Yeah.
So, we can write that. Okay. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. You guys really want to write that every single time? A lot of our problems are going to come down to this. It's either you're going to stop at step 4 because it's going to say state the two triangles are congruent, or it's going to say state something about the triangles are the same or congruent. So I don't want to write corresponding parts of congruent triangles are congruent. Instead, write this. CPCTC. Corresponding parts of congruent triangles are congruent. So instead of writing that whole phrase, you just have to write that. Okay, your homework from day 1 was none. Day 2 is 9, 11, 20, and 21. Guys, problem 11 is a lot like the problem we just outlined together. I skipped over problem 10. I'll do that tomorrow because tomorrow actually just as you stop at proving that two triangles are congruent. And then what we'll do is we'll start to break into some worksheets so that we can start doing more and more of these to get comfortable with them. Have a great day.